Okay, so the problem is you need 25% acid solution for a certain test, but your supplier only ships a 10% solution and a 30% solution. So 10% acid, 30% acid. Rather than pay the hefty surcharge to have the supplier make a 25% solution, you decide to mix the 10% solution with the 30% solution to make your own 25% solution. Sounds impossible, doesn't it? Honestly, doesn't it? Sounds impossible. Right now, I mean, you look at it and thinking, how in the world am I going to do this problem? All right, so it goes on. You need 10 liters of the 25% acid solution. How many liters of the 10% and how many liters of the 30% should you use? So that's the question. All right, somebody raise your hand and tell me how to start this problem. Pamela? Okay, and what is the formula on this type of problem? Kirsten?
Amount times percentage.
The amount times, and let's be a little more specific on the percent. What is the percent? Percent what? Say it if you think you know it. Percent what? It is percent acid. I would always define what the percent is. Because again, you may get a problem where you have other things besides the acid. This solution could have been, look, the 30% solution could be 30% acid, 10% salt, and the other percent, which is what leaves 60% water. Could have been. And it could be. Do I really care the percent salt? I don't care. I don't care that part of the other 70% might be something else. It doesn't matter. Sometimes it may tell me that, though. And I have to understand, I don't really care about the salt. I'm worried about the acid. The problem's about the acid. That's the point I was trying to make to you guys earlier. So you got to focus it on what you're dealing with. And in this case, it's all about the acid. So the percent is acid, and that's going to equal, what's the last thing in the formula? The total amount, right? Okay, so what's unique about this chart versus the other charts? Andrew? Okay, and what are those? These are columns, and these are rows, so there's an extra row. So don't forget to have a third row. Again, I always like my equal column, right? Clean that up a little bit. What would be the next step? Next step. Kaylin?
Label the bottom row mix.
Okay, the bottom row is definitely the mix. And that's the easy one. And then you were going to say label the other two rows. So how are we going to label the other two rows? So how would you label those two rows? Look at the problem and try to figure out what you would call the other two rows. Who wants to go for this one? Other two rows. Come on. What's the problem about other two rows? Other two rows. Ethan?
Your solution, like one column can be your solution.
Well, not a column, but row. So your solution is going to be the mix. We've already got that one covered, right? So the mix is what we're after. John?
10% acid and 30% acid.
Yeah, the one row is the 10% and the other row is the 30%. The two things you have that you're going to mix together, right? Isn't that what we're mixing together? The 10% acid solution and the 30% acid solution? Okay, we have 9 blocks to fill in. Somebody raise their hand and give me one. I just want one block. I want one block. Just one block. Come on, participate. Think and participate. I see the same hands up. And thank you Those of you that have your hands up. Come on, the rest of you participate. Ashton, give me a block.
10 liters in the mix amount box.
10 liters in the mix amount box. So right here. How many of you would fill that in first? Let me see your hands. You would fill that in first. Okay. I don't advise it. What do I advise you fill in first? John?
The X block.
The variable. Fill in the variable column first. Get those two done and then start worrying about other stuff. So where do our variables go here? Nick, where do our variables go?
The amount column for the 10% and the 30%.
Correct. And what do you want to use?
X and Y.
All right. So 10% we'll call X and 30% we'll call Y. I would always fill in the variable column first because you know what the problem's asking. It asks how many liters of 10% solution and 30% solution should you use? That's the amount of 10%. How many? That's the amount of 30%. How many? Get those two blocks out of the way first. Then start worrying about other things. All right, so Ashton, now give me another block.
10 liters in the mix amount.
10 liters is the mix amount. I agree. All right, we got 6 blocks to go. Somebody else give me a block. Come on, participate. Give me a block. Everybody should have their hand up for a block right now. There are lots of easy ones to go. Sam, give me a block.
10% in the acid color in the X.
So like this, is that what you want?
Yes.
How many agree with that? How many disagree with that? Wow, that's amazing that only that few disagree. Alexandra, why do you disagree?
It should be in decimal.
It should be in decimal form. So right concept, Sam, just remember you're going decimal form, right? Our percents are always in decimal form. Yeah, isn't the 10% solution 10% acid? All right, that's the column. I even told you, look, don't put percent there, put percent acid. Because you got to think, all right, what is this? What percent acid is 10% solution? 10% acid. Therefore, right here, we're going to put 0.3, right? And you don't need the 0 there. It could be just 0.3. Okay, now we only got 4 blocks to go. I need another block. Andrew, give me another block.
0.25 for the percent of acid.
For the mix. And I agree, the mix is 25%, so 0.25, right? Okay, we're rolling. We're rolling. Somebody give me another block. We got 3 to go. Kirsten, give me a block.
10 for the 10%.
Okay, 0.1 or 0.10x is the total for the acid, right? I took the amount, she took the amount x, and multiplied it times 0.1. Therefore, for the 30% solution, the total is going to be 0.3y. And people are scurrying for their calculators to figure out the total of the mix. And the total of the mix is 2.5. Okay, chart's done. Chart is done. Somebody raise their hand and tell me where the equations come from. Raquel, where do the equations come from? The variable columns. So we have an amount equation, right? And class, what kind of equations are the equations in mixture problems? Totals. So again, when you set it up this way, it's a total. So somebody tell me the total equation for the amount. Tell me what to write. Tell me what to write. Antonio, tell me what to write for the equation for the amount.
X equals Y.
Okay, that would be a comparison, but at least you're thinking. Adam, give me the total equation.
0.1x
not for the amount, right? So we're talking about the amount right now. Gotta be careful because you got an amount equation that is a total equation, not a comparison. You also have a total column, and I know you're doing the total column. So give me the amount equation. All right, Alexandra?
X plus Y equals
Yeah, x plus y equals 10. X plus y equals 10. The 10% and the 30% ends up equaling the total amount of the mix, the 10 liters. And as Raquel said, the equations come from the variable columns. So our second equation comes from the total column, which again is also a total equation. Adam, give me the total equation for the total column.
1x plus 3y equals 2.5.
Correct. 0.1x plus 0.3y equals 2.5. Okay, we've got our two equations. All right, we're not going to solve by graphing. So somebody tell me, what are the other two methods? Eduardo, what are the other two methods? Substitution and elimination. Abby, which one do you want to go for, substitution or elimination? I would definitely go with substitution. So we're going to solve by substitution. Okay, I'm going to pause at this point, and I want you guys to finish this and make sure you answer the question at the end. Go ahead and finish the problem. Hope your answer makes sense. What was asked demands. Okay, I solved the first one for x. You could have solved it for y. That'll be okay. You'll end up in the same place eventually. I then subbed in that value into the green equation for x. Careful with your decimals. When I distributed, I got 1 minus 0.1y plus 0.3y equals 2.5. I added a negative 1 to both sides to move my 1. I also added my like terms, which was 0.2y. So I divided both sides by 0.2, and I got 7.5 liters. And I looked at what y was in my chart, and y was the 30% acid. So therefore I said 7.5 liters of 30% acid. How many had that? And therefore then to finish it out, remember in substitution, you then take your circled equation, sub in that value you just found in for the variable in that circled equation. That gave me 2.5 liters. Again, I looked at my chart and X was 10% acid. So he used 7.5 liters of the 30% and 2.5 liters of the 10% to get that 25%. I don't know if your mom ever wants you to reduce a recipe or not, but this would be a way of doing that. There are a lot of type solution problems for a mixture type problem, and this is the concept. Adriana.
Could you say like 10% equals 2.5 liters?
You're better off saying 10% acid, just being more clear in your label. Just be a little bit more clear in your label. Though I didn't need to be clear in labeling my row, I definitely want my final answer to be as clear as I can make it. Okay? Kirsten.
So then, if you put, it would be clear if you put 30% solution.
I would say 30% acid solution. I would include what that 30% is. I'd just be clear in my final answer. Any other questions? Anybody else? Okay, so that's what you got to do tonight. You guys already have on your notes the problems for tonight, 13, 15, 18, 20, and then those you B minus and a greater than B minus, so B and above, you're doing 28. All right, 4 problems tonight. When you get done with your quiz, you may begin to work on the homework. All right, so let's get ready for the quiz.